Welcome back. Today we're going to be talking about the distributive property day number 1. So obviously we're going to spend a few days on this, so just be prepared. So our content objective is students will be able to simplify expressions using the distributive property. The language objective is students will be able to state distributive problems correctly, so you should be able to read them correctly by the end of the lesson. Why am I learning this? Well, it's important for many math problems such as solving multi-step equations, also for doing some mental math. So background knowledge from 6th grade is you should have gone over the distributive property. So A times the quantity B plus C is going to basically be A times B plus A times C, or A times the quantity of B minus C is the same, it's equivalent to A times B minus A times C. So in this example here, according to order of operations, I would just simplify what's inside the parentheses. So I would do 4 plus 5 is 9, so 3 times 9 is 27. Now using the distributive property, I would distribute 3 to 4, and then the 3 to 5, which would give me 12 plus 15, which gives me 27. So notice they're the same answers, and you're probably wondering, wait, why would I do that if I can get the answer a lot quicker just simply using order of operations? Well, it's because you're going to have to know how to do it when we work with algebraic expressions and multi-step equations. So let me show you an example. Here, we would read this as 3 times the quantity x plus 2. So this essentially means 3 groups of x plus 2. So if I take 3 groups of that, I'm going to basically, that's repeated addition. I'm going to use the commutative property and rearrange it so all the x's together and all the 2's are together. So again, this is the commutative property of addition. Then I'm just going to simplify and say there's 3 x's, and then this totals to 6, so 3x plus 6. That's just me simplifying. So that's an option. Now using the distributive property, all I would have to do is say, okay, I'm distributing a 3 to x and a positive 2. So 3 times x is 3x. 3 times 2 is a 6, but notice I need to determine the sign. Is it plus? Is it minus? Since it's a positive 3 times a positive 2, that's going to be a plus 6. Notice this is a lot quicker than writing this all out. So it does help us a lot. So with that said, let's go ahead and take a look at some examples. So here, this means 5 times the quantity x plus 3. So notice we're distributing a 5. We're going to distribute it to an x and a positive 3. So I'm going to distribute 5 times x, which is 5x. 5 times a positive 3 was going to be a positive 15. I'm going to repeat the process here for number 2. We're going to be distributing a 6 to the first term of y and the second term of 7. Notice I even take the sign. That is very helpful. So please make sure you always take the sign in front of the number. That way we know it's a negative or a positive, and you'll see in a little bit what that's going to look like. So here we're distributing a 6, so 6 times y is 6y. 6 times a positive 7 is a positive 42. Now looking at number 3, notice we're distributing a 3 to an m and a minus 8. So what do I do there? Well, just like before with subtraction, we always want to turn it into an addition problem. So we're just going to add the opposite, so it's plus a negative 8. So 3 times m is 3m. 3 times a negative 8 is plus a negative 24. Now we typically wouldn't write this, we would just simplify it to 3m minus 24. So same idea here for number 4. We are distributing a 4 to 3 and to a minus y. Notice you only go up to the parentheses. So here 4 times 3 is 12. 4 times minus y. What do I need to do there? I need to add the opposite. So a 4 times a negative y is going to be plus a negative 4y. So here you don't have to, but it's going to be good practice for you to always write the variable term first. So that is a negative 4y. And then I'm just going to add that to the plus 12. And there you have it. So please note when it's subtraction, we want to just remind ourselves I'm going to add the opposite, and everything else is just the same. Okay, what about number 5? This one's slightly different. It's 3x plus 5 times 4. Now, technically, you could think of this as the same as a 4 in the front, using simply the commutative property. I'm allowed to do that with both multiplication and addition. So I'm going to imagine if it was like that. So I'm basically doing 4 times the quantity, 3x plus 5. So I'm distributing a 4 to a 3x and a positive 5. Notice everything within the parentheses at this point is circled. So we're going to do 4 times 3x, which is 12x. 4 times 5 is going to be a positive 20. And there you have it. Now for number 6, same idea. We're imagining that this is in front, so this is using the commutative property. Now you don't really need to imagine in the front. If you like it here, it's totally fine. I'm going to be distributing a negative 2 to what numbers? A 4n and a positive 7. And again, notice I don't even hesitate. I take the sign up front so I know if it's plus or minus. So we're going to do negative 2 times 4n. That's going to be a negative 8n. We're going to do negative 2 times a positive 7. That's going to be a negative 14. So you're going to go ahead and try number 7 by yourself. So the very first thing you should do is recognize you're distributing a negative 6. To which terms? The 5y and to the minus 9. So here you're going to distribute negative 6 to 5. That's going to be a negative 30y. And then here, negative 6 to a minus 9. So we're just going to add the opposite. So that's basically a negative 6 times a negative 9. So that's going to be basically a plus a positive. So let me just put plus 54. So hopefully that was the answer that you got. Okay, so now we're going to kick it up a notch. We're going to do some distributing, and we're going to pull in some of the stuff we've learned from a previous lesson. We're not only going to distribute, but we're going to combine like terms. So here, when we talk about distributing and combining like terms, we need to consider what comes first. Well, distributive property is multiplication. Combining like terms is in a sense addition. So what comes first according to the order of operations? If you guess distributive property, you're right because we're going to multiply first. So let's do that. I'm going to distribute a 7 to the term x and positive 4. 7 times x is 7x. 7 times positive 4 is 28. Notice you can't just put 28 by itself because then it kind of looks like 7 times 28, so you definitely want to put plus. Okay, now I'm just going to bring down this plus 2x. Now I can go ahead and combine like terms. If we have 7x and we add 2x's to that, I'm left with 9x. So we have 9x plus 28. Now can I combine these two terms? The answer is no, because this is a variable and this is a constant. They are unlike terms, so I'm not going to combine them any further than that. Okay, so number 12 is a little tricky. For number 12, you have to be careful. What are you distributing? You are distributing a negative 3. Remember, we always take the sign in front of the number, so this is a negative 3. Or you could think of it as, hey, we're going to add the opposite. Oh, look, it's a negative 3. So we're going to go ahead and circle the first term, which is x, and the second term, which is positive 1. So we're going to distribute negative 3 times x is a negative 3x. A negative 3 times a positive 1 is a plus negative 3. I'm going to go ahead and bring down this 5x. So now at this stage, I'm going to combine like terms because I can. If I take 5x and I subtract 3x, I'm going to be left with 2x. This is just basically minus 3. And there you have it. So I'm going to go ahead and do one more example. Then I'm going to have you try the next 3 by yourself. So here, again, you should ask yourself, what are we distributing? We're distributing this minus 2. So if we add the opposite, that's basically a negative 2. We're going to distribute it to a 4 and a positive a. So note something. You can go distribute with the arcs over if you want. You can also distribute underneath. A negative 2 times a 4, that's going to be plus a negative 8. And then the negative 2 times a is just plus a negative 2a. I'm going to go ahead and bring everything else down. So I'm going to go ahead and put minus 1 and then put a here. Just so that things can get cleaned up, I'm going to add the opposite so that I can see that's a negative 1. I'm going to combine a with plus a negative a. If I have a plus a negative a, I'm going to be left with a negative 1a. And I'm going to combine a plus negative 8 with a plus negative 1. There are definitely more negatives. Altogether, there would be 9 more than there are positives. So that is our answer. So at this point, I'd like you to go ahead and try numbers 14, 15, and 16 by yourself. Okay, so for number 14, we are distributing a 3 to b and negative 2. And we can see this as add the opposite, and then you can clearly see it is a negative 2. 3 times b is 3b. 3 times a plus negative 2 is just basically a negative 6. And then notice here, I'm not distributing. I only distribute within the parentheses. So I'm just going to bring down the plus 6b. Now at this point, I can combine like terms, always circling the sign in front of the term. So I have 3b plus 6b, that's going to give me 9b. Bring down the minus 6. Notice I can't combine anymore, and that is my answer. So that one wasn't too bad. Now let's look at number 15. We are distributing a 2 to 3m and positive 1. 2 times 3m is 6m. 2 times 1 is 2, and I'm going to bring down this minus 4m. So now I can just go ahead and add the opposite. I'm going to combine the 6m with a plus negative 4m. So if I take 6m and I add a negative 4m, I'm left with 2m. Then I bring down this plus 2. Notice I can't combine them. They are unlike terms. One is a variable, one is a constant. So that is my simplified expression. Number 16, same idea. We're distributing a 3. We're distributing it to k and to positive m. Notice I stop within the parentheses. 3 times k is 3k. 3 times m is positive 3m. Now here, notice we are distributing a minus 5. So I'm going to go ahead and add the opposite. So it's basically a negative 5. We're distributing to a k and to a positive 2m. So negative 5k, we're going to add a negative 5k here. Negative 5 times a positive 2 is going to be plus a negative 10m. Now I can go ahead and combine like terms. I'm going to combine the k's together. 3k plus a negative 5k is going to be left with negative 2k. And then positive 3m plus a negative 10m is going to be plus a negative 7m, which is just minus 7m. Now, what else can we use distributive property for? Well, we can use it for mental math. Okay, so let me give you some examples. We're able to do this because we're utilizing the commutative property. So here, I can go ahead and kind of cut 102 into 102. Now I can distribute what's 20 times 100. And then I'm going to do what's 20 times 2. And then I'm going to simplify. Well, this is 2,000. This is 40. What's 2,000 plus 40? 2,040. Now, in an example like this, you can do the same and cut it up to 40 plus 9. Or you can say, hey, that's basically 50 minus 1. So I'm going to distribute 8 times 50. And then do minus 8 times 1. So this is going to give me 400 minus 8, which is just 392. Okay, so now, number 19, same idea. I can go ahead and distribute 4 times the quantity 100 plus 8. 4 times 100 plus 4 times 8 is going to give me 400 plus 32, which is 432. Number 20, same idea, except instead of saying 100 plus 90 plus 9, I might find it easier to cut 199 as to 200 minus 1. So if we distribute 9 times 200 minus 9 times 1, which is 1,800 minus 9, which is 1,791. So this allows us to do mental math. Okay, so at this point, I'd like you to pause the video and try these two by yourself. Okay, so for number 20, you could have done 5 times the quantity 60 minus 1. Now, could you have also done 50 plus 9? Yes, it would work just the same. Some might be a little bit easier to calculate, so just keep that in mind. 5 times 60, and then we're going to do minus 5 times 1, which is just 300 minus 5, which is 295, so hopefully that was your answer. Number 22, I'm going to go ahead and do 7 times the quantity 300 plus 2. 7 times 300, then 7 times 2 is going to give us 2100 plus 14, which is just 2114. Okay, so guess what? That concludes the lesson for today. Thank you so much for tuning in. And as always, until next time, bye.